Hello students, today we apply binary search on string type data. So last class we practiced on integer type data, means the search element what we were searching, it was on integer type, and today we are searching on string type. As you all know, the comparison sign what we use, like a greater sign, lesser sign, what we had applied in the last class for integer type data, that sign cannot be applied for string type. So here today we are learning one string accessor method, that is compare to command today. So we learn this, how exactly this command is working, then we'll see how we are going to make use of this command in a program. So let me explain the command compare to. The method name is compare to, which is applicable for strings, where it is going to compare two strings. Based on the comparison, it will give you the answer in terms of integer. So the return type of this command is integer type. That's what I have written here, the very first point. I'll explain the second point with an example. Once I explain the example, then I'll come back and I'll list out all these points, what exactly this command is working, how exactly the command is working. So here compare to command works in a lexicographically manner, means in a dictionary order it checks. So you have seen your dictionary where exactly in alphabetical order it goes. If the first letter is common, then it will go with the second letter. In that order it checks. In the same manner, even compare to command is also working. Let me explain the example. So I'll take one string S1 with the data Adit here, and one more string with the data Abhi. If you see the example, first string S1 dot, I am applying compare to command for S2. Second string I have given it in a bracket. This is how the syntax of the compare to command. So before compare to, what you give will be called the very first string. What you give it in a bracket will be the second string. When you apply compare to command, it will give you the difference between these two strings S1 and S2. The difference will be given to you. So the return type will be in terms of integer. So I am collecting in one integer variable int result. Let me explain how the command is working. If you see the example, the very first letter of both the strings, A here and here also the letter A, both are same. So it goes with the second letter. So the second letter is D here. Here the second letter is B. There is a difference in these two letters. So it stops the comparison immediately and it will give you the difference between these two letters. So I have written here, first letters of both the strings are same. So it goes with the second letter. There is a difference. It will take the ASCII value of those letters. So in that S1 string, the letter D, ASCII value of that is 100. If you can recall, small letter A starts with 97, small b is 98, it goes on. So accordingly the ASCII value of D is 100. You can check that. Starting from A 97, you can check for B, C, D. You will get the ASCII value of D letter as 100. Second string, the second letter B. If you see this letter, so I have extracted that letter here. So if you take that letter, ASCII value of that is 98. If you subtract the first ASCII value, that is D letter ASCII value, from the second string, the second letter, if you subtract those two, you will get the answer as 2. 100 minus 98 will be, you will be getting it as 2. If you compare, means the very first string is bigger than the second string. So result will be in terms of positive. So when string 1 is bigger than the string 2, the compare to command will give you a positive result. So that is what positive result is, nothing but above 0. So what answer we are getting is 2 here. So which is a positive number. Same example, now I interchange the value. Second example, same data I have taken, but if you see the command, I have interchanged the position. So what you give before compare to will be the very first string. I have put an arrow and I have written here. Though I have written S2 here, the command what you write, means the string what you write before the command will be called a first string. What you give it in a bracket will be the second string. So here if you compare s2 dot compare to s1, if you write, so when we compare, here the letter A and here A common, it goes with the second letter. So what we have done is s2 dot compare to, in that s2 the second letter is B, the second letter is B here, you can see that s2, the second letter is B, ASCII value of B is 98. Then what I have given in the bracket is the string 1, string 1 the second letter is D, because there is a difference in these two letters, so it stops continuation of the comparing, immediately it will give you the difference. So ASCII value of D is 100, as I told you, you can check this. So 98, if you subtract the values of these ASCII values, the very first string subtracted with the second string, so if you do that you will get -2, because here first string what you are comparing, the very first string ASCII value is less than the second string. In that case your answer will be in negative, which is less than 0. Less than 0 is nothing but a negative number, but here you will get the exact difference as -2. So here when you apply the command like this, so integer result is equal to s2 dot compare to s1, you will be getting the result as -2, which is the exact difference between those two letters, which is nothing but a negative number. How do we tell the negative number? Which is less than 0, a negative number. But compare to will give you the exact difference how much you are getting. So here I can conclude that when string 1 means the very first string, when it is less than the second string, you will get the negative answer. When the first string is above the second string, you will get a positive number. What positive number? Only when you do this calculation you will get what exactly that number is. When third example, I have taken both the data, same data I have taken here, Adit, and here also second name, both are same now. So when you apply a compare to command for these two strings, if you observe the data are same, you will get the answer as 0, because both the strings are equal. So when strings are equal, you will get the answer as 0. So I can conclude the compare to command something like this. Now let me come back and explain or summarize the points what I have written here. So first point is compare to command will give you the answer in terms of integer, and compare to command, it checks two strings in a lexicographically, means in a dictionary order. If the string 1 is bigger than the string 2, then it gives you the positive result, which is above 0. When the string 1 is lesser than the second string, then it will give you the answer in terms of a negative, which is a less than 0. When both the strings are equal, you will get the result as 0. That's the third case. So compare to command is to compare whether or to check which string is bigger, smaller, something like this. And do not confuse this with the equals or equals ignore case. Equals or equals ignore case is a command to compare two strings whether they are equal or not. So it checks only for equal, whereas compare to command will tell you which string is bigger, smaller, or whether both are equal. So it is something like checking, because in binary search where we are going to compare the search element with the middle element, for that reason compare to command will be used. Whereas in linear search you will go with the exact match by writing something like this, double is equal to sign. This way we cannot use, where you are using equals command instead of this. For the string type data, equals command you write. But whereas in binary search you check whether search is above the whatever the middle number or something like nm of middle element. So in that case I cannot apply this greater sign, lesser sign for strings. For that reason we use compare to command. Compare to. So the command how we apply will be compare to like this. The syntax here I have written here the strings. Okay, the return type is integer, command works like this. So this is how the command compare to command works. So with this, how exactly we are making use of this particular command in a program, I'll explain. Directly I'll give you the evaluation of the program, then I'll give you a demo of execution. I have taken one array here, where I have taken one array. If you see this array here, I have initialized an array with 5 name, and students please observe here, in binary search there is a condition on what list we are searching should be in a sorted order. So I have initialized an array with a sorted order. I am taking the search element as an argument here. Search will be an argument. So initial value of boolean flag value is false. All of you know this concept. Here I have taken one integer result. Just now I explained. When I compare two string, I will get the difference. To collect that difference, I have taken one extra variable here, integer result. Then continue with that lower limit, upper limit, middle value, all these are remains to be same. So here in the beginning, since I have taken the array name as, so initial value of array is nm, array name is nm, so I have taken here nm dot length, so it will give you 5. So 5 minus 1, so if you observe here, array length is 5, 5 minus 1, so initial value of u will be set with 4. So I can show that example here. So lower limit is set to 0, upper limit is set to now 4. So upper limit is pointing to 4. These are all the array names what I have taken for nm array. So this is what the initialization, this is a working part what I have taken here. So I have taken this. Then initially in the beginning evaluation part, 0 is less than or equal to 5, condition true, it comes in here. M value we are going to calculate. Okay, step by step, iteration by iteration, how exactly it is working. I have given the steps here. So first it will come to this M is equal to L. So initial value of L is 0, 0 plus upper limit is 4. If you divide that by 2, you will get the initial value as 2 here. That is what the middle value. So here let me take one example where I am searching the data Banu. Search data is Banu here. So middle data I am taken here, that is a middle element, index number I got it as 2. So now middle index is pointing to 2. So in binary search, as you all know, we divide the list into 2. So this is a lower limit, this is upper limit, this is what the middle element now. Index number is pointing to 2. So here result is equal to search dot compare to, because I have to compare whether the search element is greater than the middle element or whether the search element is lesser than the middle element, so that I can take the first half of an array for the next searching purpose, or I can take the second half of the array. That is the reason I have taken the middle element, as you all know in the previous example also. So here the search data is Banu here, comparing that with nm of m. M is pointing to 2. If you see here, so nm of m is nothing but the data what we have here, it is, okay, I will write the shoe, correct. So if you see the ASCII value of this B ASCII value, just I have written one small table here just for you to refer this. So I have taken B ASCII value, the very first letter B and D, there is a difference, immediately it will give you the ASCII value of, means the difference of these two letters. ASCII value of B, the very first letter B is 66, and ASCII value of D, the very first letter of the middle element D is 68. The difference 66 minus 68, you will get the negative number, means the first string is smaller than the second string, means the search element what you are checking in this list is lesser than the middle element, so that you have to apply searching in the first half of the array. So today I have taken how exactly we are getting the search element in the first half. Why? Because last class we have taken the second half of the array for searching. So I have taken a different example. First half means how the upper limit will be keep on, like how exactly it changes the position. For that reason I have taken the first half of an example today. So here you are getting minus 2. So here the result value I can write here, result is minus, means which is a negative number. So my if condition goes like this, if result is greater than 0 means when my search is above the middle element. But in our example our search is lesser than the middle element. So it goes to the else condition. So here I can write here else if result is less than 0 because it's a negative number, condition true, u is equal to m minus 1. This condition has become now true. Upper limit will be changed to m minus 1 location. So now m is pointing to 2. 2 minus 1 which is equal to 1 will be the upper limit. So upper limit is changed from 4th location to 1 location now. So upper limit is pointing to 1. So after this, entering into this else part, it will go back to the loop. Now here lower limit is 0, 0 is less than or equal to 5, condition true, comes in upper limit value is not 5, it is 1 now. Upper limit is 1, lower limit is 0, just now we checked. So condition true, again it comes in here, m is equal to L plus u divided by 2. So now m will be, so 0 plus 1 divided by 2. When you try to divide, you will get the answer as 0. 0 is the searching divided by, actually upper limit is, so here now we get the value 0 plus 1 divided by 2 which is equal to 0. So m value is now 0. So here now no more m is pointing to 2, now m is pointing to 0 location. So both m, l both are pointing to 0. Now when we apply search dot compare to nm of 0, because middle element is pointing to 0 now. So accordingly search is Banu, middle element will be now Anu. So here when it takes the data as Anu, so the ASCII value of A will be, now here ASCII value of A will get changed to 65. So the difference what you are getting is, so result will be 1 now. So result what you are getting is 1, difference between these two strings when you compare the search element with the middle element. Now when we check if result is above 0, yes, condition true here, result is 1, 1 is above 0, condition true. So immediately lower limit will be changed to m plus 1 location, means 0 plus 1 which is equal to 1 location. So accordingly lower limit will be changed to the location now 1. So now upper limit and lower limit both are pointing to 1 location. After doing this, it won't go to the else if and else part, immediately it will loop back. When it loops back, lower limit value is 1, upper limit value is also 1, condition true, it comes into the loop body here. Now middle value we have to calculate, that is in the third step, m value will be, lower limit is 1 plus upper limit is also 1, if you divide that by 2, so it becomes now 2 divided by 2 which is equal to 1. So m will be pointing to 1 location. So m is no more pointing to 0. Now both, all the three, lower limit, upper limit, even middle value is also pointing to 1. Middle value is also pointing to 1 now. So after this it comes and reaches the statement result is equal to, so search dot compare to means search is the data, middle value, nm of middle value is pointing to 1. So I can write like this, okay, both, even middle is also pointing to 1 here. I can show that because the width is not sufficient, I am displaying it here. So M is also pointing to the same index number. So here search dot compared to nm of 1. So nm of 1 is what? Now data is Banu. If you take the ASCII value of that, now ASCII value of letter B is 66. Here letter B is also 66. If you do that, if you do the subtraction between these two, the result will be 0 because both the datas are same. So here result value what we are getting is 0 in the next case, that is in the step 3 we are getting the result as 0. So it comes and checks here, if result is above 0, condition false. It will go to the else if condition where it is checking whether result is less than 0, again condition false because result is equal to 0. It comes to the next condition here. So where else it is not above, it is not lesser, obviously it has to be. Why? Because M is pointing to the one location, the data is Banu, search element is also Banu, so both are same, it is matching. So here you will get the value as flag will be set to true, flag is set to true, and it comes out of break statement, will take the control out of the loop. So it comes and reaches this element found at position m plus 1. Now if you see that m location, m is pointing to 1, m plus 1 will be 1 plus 1 2, because to the end user this is the first location, this is the second location. So it will display search element is found at location 2. If you do step by step evaluation, iteration by iteration, you will get the answer, and result calculation how exactly you are getting, that is what the step I have given it here. So this is what the difference values you are getting it. Same program, now I will give you a demo of this. So I have written the same program here, working everything is same. The question is, write a program to initialize an array with any 5 names. Search for name, if found display element found at position, I want the position of that name, otherwise display name not found. So this is the question. Program the same, just now what I give you the evaluation. Now here length is 5 minus 1, so it's supposed to be 4 here. So result value I have given the comment here to take the correct difference between the two strings. So this is what the reference we are collecting. A small change compared to your integer type to string type, this is the only change, and here whenever you write if condition you have to check the result value. This is a change between the integer type and string type. The rest of the logic, everything remains to be the same. So let me compile. I will give you the execution. Search element, suppose if I am trying to search for an element what we are searching is the string type. As I told you, I am searching for Banu. The same example, element found at location 2. Similarly, same example, one more I have taken where we are taking 2 array. So second question, same string type searching only. Write a program to initialize an array with 5 employee name along with the department. Search for employee name, if found display employee name along with department, otherwise display employee name not found. So only difference between the previous question to this one, along with the employee name I have taken the same array as employee name, and one more array the corresponding departments are stored. So searching everything remains the same. Here also array size is 5, 5 minus 1 initial value of upper limit is set with 4. Everything, only thing is result command, means search compared to command we are applying, and we are getting the difference of those two strings, and that result value we are checking. Based on that result we are changing the position of lower limit and upper limit. Same thing how we do for integer type, same concept. Only thing is this step is extra here. Then while displaying, since it's more than one output or more than one statement to be displayed, we have used a block here. We are using employee name and department. We are displaying out on the screen. So here two output statement, name and department. So let me compile. Okay, let me make this as comment now. So only change 2 array I have taken. Concept is different now. So I am searching for the name Ganesh I give here. So Ganesh general. You can cross check whether we are getting the same or correct output or not by going to the program. Here if you see that the name what I searched was Ganesh. So if you see there 1, 2, 3, 4, fourth name 1, 2, 3, fourth, that department is what? So Ganesh belongs to general department. That's what the output I got it here. That's how binary search works. Please be careful students, whenever you write any program, on which field you are searching. If you see the question here, search for employee name, means that name field should be in a sorted order. Accordingly you are taking the department. So on whichever field you are searching in a binary search, that particular field has to be in a sorted order. That is what you have to take care in binary search. So along with this video, I am giving you one PDF file. In that PDF file, what I explained today is that compared to command notes are there. Along with that, today what we practiced, 2 program, that is searching for name and displaying position. One more is name and department, that program also you have. Along with that, I have given you 3 homework questions. So what I have given you is for string type searching. So one for initializing, reading, and one is taking array as an argument, like how I gave you in the last class, same. But only thing is the search type is string today. So beginning of this PDF file, last class I gave you 3 homework questions. So that question answers I have given here. You can cross verify your program with the solution what I have given you here. So 3 homework program solution and today's explanation of binary search, the command, then the 2 programs along with that homework. Please download this file, take a printout, and this will be for your future reference or as a study material. You can keep it, and the same thing you please try it on the system and check for the input and output. Thank you students.